So for homework 6, we had to make a UML diagram for undirected graph. And for this homework, we had two diagrams that we had to make. One of them was a class diagram, and the other one is an object diagram. So an easier way to think about a class diagram is if you were to take, say, homework 5's shape.cpp shape class, and if you were to simplify that class into a box to abstract the entire concept, this is kind of what your class diagram would look like. So in homework 6, instead of doing a shape, we're doing for undirected graph, which undirected graphs have node points, which are also called vertexes, and they have connections, which are called links. So this is what our class diagram would look like. You really only need one class for this, and that is your endpoints. So these are your vertexes or your node class. And you have this association back to itself. So this association back to itself is kind of our way of saying a vertex can connect to another vertex. And that's the same as saying vertex, edge, vertex. A lot of students actually had a vertex and then the vertex connecting to another edge class. Well, this is technically not incorrect. This is really bad design because you're kind of adding a lot of extra classes that don't necessarily have to exist. Your lead TA Salman kind of touched on this in your homework 6 FAQ post on Piazza. So with a lot of students had edge here instead of connect. So this is your verb. So your label is your verb of what this association actually does with the class. So in this case, our vertex connects to another vertex, which is why we had connect here. In your lecture slides, we had an airport serves a city. So serves actually appeared there in the slides instead. So make sure you don't confuse that. This is your verb connect and not the noun edge. Multiplicities. So a lot of students had either wrong multiplicities or missing one edge. So what this is saying, having 0 dot dot star on both ends, is that any vertex can connect from and to 0 to any number of vertex. So your vertex can be standing by itself, and the vertex can be kind of connected to as many vertexes as you want. 1 second, I'm gonna pause this video. Okay, so your vertex class kind of have a name, probably an attribute, and then it might have some constructors and a connect method. For homework 6, we just wanted an attribute, and some students didn't have that. And all this really is just name string is the type of it. So in an actual CPP file, you would have a string name in your vertex class. Now moving on to the object diagram. So this is for the second requirement. We're tasked to make a kind of snapshot of a program that looks like this with 1 to 3 vertexes connecting in a circle almost, and then your 4 kind of connects off to the edge with 3 here. So this is what an example object diagram looks like. You have your instances of each class, so v1, v2, v3 connecting in a circle. Again, note that these days connects instead. And then you have your 4 kind of off to the side. And object diagrams do not have multiplicities in them. Multiplicities are exclusively for class diagrams to kind of tell how each class relates to each other. So I think all I want to say about this, so the v1 that we see here do not have to match. What this is saying is, so my v1 vertex, this is the same as if I were to, let me swap my screen over. If I were to kind of make this in an actual program, vertex foo equals to new vertex. This is the name of our object. So if we look back at the graph, foo would be where v1 is. So this would be where v1 is, would be foo in my program, and then name equals to v1. This would be, if I go back to my program, this would be set name bar. So I just wanted to point out that these two do not have to match. This is an attribute of your vertex class, which is shown here, and then this v1 here is the name of your vertex. So this v1 here is the name of your entire object here, and then this v1 is kind of the attribute of this object. And that's it for homework 6. Thank you for watching.